This week we're going to talk about array formulas. Let's have a look at the example of this week where we are looking at exam results for a teacher.
We interrupt this recording for an important message about types.
Today we're going to talk about type theory because it's super important in order for us to be able to understand this week's material. So we're going to start really basic, so don't worry. This is easy, right? 2 plus 3 is 5. But these are not just numbers, they also have the type of being a number. And I'm going to annotate all types with a different color. So what we are calculating here is a number, and a number result in a number. But this is not how we write formulas in Excel. Well, we can write numbers in a formula, but we can also use cells. So let's have a look at how that looks. So we have these two cells in a spreadsheet, and we can say A1 plus A2, in this case, is also 5. So what are the types here? Well, 5 is a number, that's easy, but A1 is not a number, it's a cell, it's a reference to a number. So let's draw it like this. And say something that contains a number and something that contains a number. We can add the numbers and then we can get a number. There are different types in Excel as well. It's not just numbers. Suppose we have this in a cell, a string, a piece of text. We can calculate on text as well. So what are the types here? We have, again, something that contains a text, and the result of the function is a text. So these functions all take in the same values, a number resulting in a number, or text resulting in a text. But there are also functions that can take in a certain type, but return a different type. Let's have a look at how that looks like. For instance, if we're calculating with dates. Oops. We have a date in our spreadsheet now, and we can calculate with dates as well. We've seen that in the past. We could, for instance, calculate the month of A1, which would result in 1. So here you see an example of something that takes in a certain value. It takes in a container, something that contains a cell containing a date, but it results in a number. So there you take in a date, but you return a number. So sometimes the types of the input are different from the types of the output. They don't necessarily have to match. So now let's have a look at the most complicated construction that we're going to look at in these week's videos. So it's still pretty basic, I hope. Suppose we have a range. We have 1, 2, 3 in a spreadsheet. We can calculate on that. We know how to do that. So we can say something like the sum of A1 to A3, which is in this case 6. So what are the types here? Let's start with 6, because that's super easy. 6 is a number. We know that. But what do we have here? We could say we have 3 number containers, 3 values that have a number. But of course it doesn't necessarily have to be 3. We can also say, now we're summing, we're summing until A5. Would that give the function a different type? We would have to add another container here and one here. So we're not going to do that. This is not the way that we are going to write this down. What we're saying here is we're summing over a list of numbers. So the type, as I will write that down in subsequent videos, is a list of numbers, and the result of the function is a number. And this is very important to remember for the remainder of this week's videos. That was the end of the typing sequence. Hi, welcome to this week's video. Today we're going to talk about array formulas. And we have a brand new example to work with array formulas. In this week's example, we are a teacher. And that's a nice coincidence because, of course, I'm a teacher. And this is actually quite a real-life experience of how I analyze exam results. So let's have a look at the spreadsheet that we're going to work with in this week's videos. It is about a bunch of students that are in my class. I have their student numbers, their names, and the year in which they have started. So the names, then the IDs, and the year that they started their studies. And in addition to that, I have exam results. So you see I have a number of questions, I have a list of students, and then for all of the questions I have the perfect score and the score for all of the students. And you might think that I would use this spreadsheet just to analyze the marks for the students, but that's not true. I also use the exam results as a means to analyze the quality of the exam. So I have a look at the results and I look at what question actually impacts the scores of the exams most. Let me give you an example of that. So if I look at this spreadsheet, I see that those questions 1 and 2, the answers are pretty similar. In many cases, the same score is given or a very similar score. So if I want to dig into that, what I could do, of course, is take the sum of all the scores for one question and take the sum for all the scores of the other question and compare those two together. And I can see that indeed the difference isn't that big between question 1 and 2. However, that is a bit misleading because you see in this, if I would just sum these cells, the sums would be the same, yet the answers would be very different. So the sum is not a good solution to really understand how these two questions differ from each other. So what to do? What I actually want to do is take the difference between all of the cells, between all of the results for those two questions. Let me do that. And unfortunately, double-clicking now doesn't work because there's an empty column, so I have to really drag the formula down, and then I can see the differences between all the cells. But as you can see, some differences are positive and others are negative. So we need to take the absolute value of the difference in order to get the real difference between the two questions. So we drag the absolute difference down, and now we can see, hey, is there really a difference? If we sum these values together, we see that the difference is indeed between those two questions not that big. The difference is 21, and we have 14 students, so that's about 1.5 points per student difference between those questions. So this helps me. This helps me with the analysis because now I know how these two questions relate to each other. However, I don't have 2 questions, I have 12. So if I would want to repeat this analysis for all of them, I would have to make a lot of auxiliary columns. Here you see it, there's no end to it almost. That's not what I want. I hope you remember from previous lessons that duplication is not a good thing. If you're doing the same thing over and over, if you're making a lot of columns or a lot of rows that are very similar, you have to think of me. Please think of me and think, oh no, duplication, no good. I have to go back to the MOOC and look at a smarter way to do this. So how to do this smarter? Let me first remove all those duplicate columns. We don't want them. We zoom out a little bit. And we also remove this because we're going to do this in a more compact, in a smarter way. So what we would like to do is at once subtract the question 1 from question 2 without all those intermediate cells. So this is a good attempt. We just subtract a range from another range. And let's see with the evaluate function what exactly happens here now. We have the first column. If we evaluate it, we get 8, which is the first item of the column. And this is because what Excel now calculates is the intersection. We talked about that in previous lessons. So this is close to what we want, but not exactly what we want. We don't want Excel to calculate the intersection immediately. What we would want to have is all of the differences. And this is, you can guess this probably, where array formulas come in. Because Excel can evaluate this function in 2 different ways. Let me show you how the alternatives look like. So this is sort of the normal value. The normal way of doing it is what we just did. We paste this formula in. And now the alternative way, the array way of doing it, we don't hit enter, we hit Control-Shift-Enter. And if we do that, we get this nice curly braces around the formula. And this is not good in a sense because we get the same result. So you might think there's no difference, the curly braces don't do anything. However, the way it's calculated is really, really different. What's underneath is different. And in order for us to understand the difference between those two ways of calculation, we need to use type theory. In the first version, the normal version of the minus function, this is what happens. We have the range b3 to b16, and we subtract from that the range c3 to c16. So what happens here is the reduction, the intersection between the two ranges. This is what Excel returns for a range. So this is 8, the first intersection, minus 10, the second intersection, which result in minus 2. That's what we have seen. So what happens in the alternative version, the curly braces, the array version? It looks exactly the same, but what happens inside is really, really different. So in this version, again, b3 to b16 minus c3 to c16. In the array version, no reduction takes place. Excel calculates this subtraction on the entire range. So internally, we have b3 minus c3, and then b4 minus c4, and then b5 minus c5, and I guess you can come up with the rest. And then all of these subtractions are calculated, all of them. So we get a list with 8 minus 10, 0 minus 0, 5 minus 5, etc. So the result of this array, of this curly braces version of the formula, is a list. 2, 0, 0, etc. But because there's no room for Excel to plot this entire list, we only have one cell, we only get the first version, first number in the list. But that doesn't mean that the result is a number. The result is actually a list. It looks the same, but internally it's really, really different. So let's go back and see how this looks in Excel. We don't need the glasses anymore. So if we look in our spreadsheet, we see no difference. However, internally, it's really, really different. The first version results in a number, and the second version results in a list. So what can we do with the list? It's really nice that we have a list now, but what to do? How to show and work with this list? So the first thing we can do with an array formula is give it space. Make room in the spreadsheet for Excel not to plot the first number only, but to plot the entire resulting array. So let's have a look at how that looks like. So we're going to remove the normal version and the array version so you can really see the difference. We throw them away. In the normal version, if we make room for the entire array, we put in a normal formula, nothing happens. We only get one result. But for the array version, if we make room, if we give it space, and then we hit Shift Control Enter, what happens is we get the entire resulting array. And now you see the list that we had on the blackboard. We have it now in a spreadsheet because we gave Excel room to show, hey, I have this entire array of data to give you and not just the first version. An alternative, what we can do with an array formula is flatten the list. Make this entire list into one value by adding a function around it. So we have a list, and what we can tell Excel is do something with that list. For instance, sum the list. So in a normal version, if we would sum the intersection of two ranges, we just get -2 because the result is -2. We can add a sum around it, but it will still be -2. In the array version, we get a different result. Look at how that looks like if we enter the sum around the array version of the formula. Then we get -5, because what happened now is the sum has been calculated over this entire list that has resulted from the array formula. And here you see the comparison with all the separate subtractions, and if we add a sum around that, we get the exact same value. So this, all these separate subtractions and a sum, results in the exact same thing as an array formula with a sum around it. And in this way, this is how we can solve our original problem of wanting to compare all the questions with each other. We don't need an auxiliary column and a sum. We can calculate the entire sum in one cell. And this saves us a lot of space. Let's see how that looks like. So this is all, we don't need that anymore. And we can use it now to calculate the difference between question 1 and question 2 in one cell only. So we take the sum of the entire range, the entire B range, minus the entire C range. Of course, we need the absolute, as we did in the beginning, and then Control-Shift-Enter gives us the result of 21, just as we had in the beginning. So with the use of array formulas, we have reduced a column and a sum to one cell only. That's the power of array formulas. Array formulas. We've looked at how to analyze the data for the quality of the exam. So we're not necessarily looking at the quality of students, we're looking at what questions in our exam contribute towards the end marks. And I think we can say that we've come to the conclusion that that question 2 doesn't really help. It's not different from question 1. So of course we can just clear the content, throw everything away. But that's not what I want. I manually inputted everything, so I want to keep the values, but still I want to have the ability to analyze. So I could filter, but the way the filtering works in Excel is you can only filter in this direction. You can only filter on rows, and you can't filter on columns. And that's exactly what I want, because I want to filter out one question, and I don't want to filter out one student. So what I need to do is change my data, transpose my data into being in a different direction. So how to do that? What I can do is I made another worksheet called exam transposed, where I want to transpose my data. And Excel has a function for that. I can just say transpose, type it in the formula bar. There we go, transpose, and then I select the array of data that I want to transpose. And then I hit Ctrl-Shift-Enter. So what I get now is just one cell, because as we've seen in the previous video, I haven't given Excel the room, the space, to plot the entire array. So if I want to have everything transposed, I need to make sure that there's enough room in my worksheet to plot everything. So how much room do we need? Well, we have 16 rows, so that will be 16 columns. And we have 14 columns currently, so that will be 14 rows. So if we go back to our transposed worksheet, we make sure that we make enough room for everything, and then we can use the transpose function with Ctrl-Shift-Enter, making it into an array formula, and then we get the result of the entire array. So what was previously one row is now in the transposed version one column. So why am I showing you this? Well, first of all, we want to have the results in a different direction, but I also want to point out an important difference in Excel functions. Some functions are array functions. For instance, transpose, if you enter it, you already see as an argument, you need to put in an array. So the transpose is an array function in a sense. It always operates on an array. There's no other way. You can't put in a number, it doesn't know how to transpose a number. However, other functions, like the subtract function that we've seen in the previous video, they not are inherently array formulas, but you can make them into array formulas by giving them a range as an argument, and then they can be made to work on all the pairs. So some functions are array, others can be made array, and that's also what the exercises of this video will be about. In the previous video, we looked at array formulas. More specifically, we've looked at how to transpose our data so that we can filter it for questions that we don't want to have in the exam anymore. Our data is prepared now. it's in the right way, so let's filter it. We can go to the filter button, select our data, and say, hey, we don't want all of the data, we don't want all of the questions, we only want to have the everything beside the second row. But unfortunately, we still have the same result because we have transposed everything, including the last column, which is now the last row. So don't worry, you think, we can just delete it. That doesn't work. You cannot change part of an array formula. It's impossible. Once you have selected an area that's meant for an array, you cannot delete cells in it. And this is good because you don't want to accidentally overwrite part of your array by hitting the keyboard with your elbow. But in this case, we don't want to have the final column anymore. We want to add new calculations. So what we need to do is use the same region again, but with one row less, and put the formula in, the array formula in again. So the only way we can delete the values is delete everything, delete the entire array formula, and then paste it again using one row less. It's a bit cumbersome. If you want to change an array, you have to change everything, but there we have it. So now we can add the sum function ourselves, based on the transposed data. We just add a sum of the entire column. There we go, no worries. And we drag it. Yep, there it is. So now we can filter, right? We're entirely prepared. We go to filter, we remove the second question from the list of questions, and it works. Unfortunately, it doesn't. The calculation, even though the row is filtered out, is still calculating on the entire column. So we cannot use a function to filter because it will still calculate the entire column, unfortunately. I hope you're screaming right now. I really hope that on the other side of the video, you are saying this. Hey, but I know why this isn't working, because formulas are not for analysis. Formulas are for calculation. If you want to do analysis, you should use something else. For instance, a pivot table, indeed. So, okay, I hear you. Let's try to do our analysis with a pivot table. We get rid of the formulas. They are not for analysis. We get rid of the filter, and we select all of the data and put it into a pivot table. Whoop. Filter can go. We select all of the data. Oh yeah, I've changed the student numbers into 1, 2, 3, 4 instead of the very long student numbers, because that will make the pivot table a bit too big. Let's go. We add a pivot table. Yep, there we go. Select a pivot table, and we put it on a new worksheet that I have just made. Select the data, and we have a pivot table. So now we can filter, right? We can say we want all of the students. These are the student numbers now. All the sums of all the students. Click, click, click. Yep. And we can add a filter on what questions to use. Super easy. If you've seen the week about the pivot tables, you know how to do this. We can just select what questions we want. However, as you see, it's pretty hard to compare the different scenarios with each other. Now this is 55. I change a value, it changes. But what I would like to have is have the scenarios side by side. One row for the exam with question 2 included, and one row for the exam without question 2, without everything swapping all the time. If I do that, the only way I could do that is to make 2 pivot tables with 2 different filters. And then, of course, we're running into the duplication problem again. And there's another downside of using pivot tables for this analysis. If we go to the table field settings down here, there's a limited number of functions we can use. So there's sum, average, min, max, but not all of Excel's, I think, 350 plus built-in functions are there. There's a limited set of functions that we can use. So if we're summing the exam results, that's fine. But if we want to take different quartiles, for instance, we want to use the median, or we want to use the mode, then there's no way that we can do that with a pivot table. So in conclusion, yes, Formulas are for calculation and not for analysis. However, there are some limitations to what you can do with pivot tables because they don't support everything, and also they don't really support scenario analysis in which I want to compare two different filters with each other. And that's where you're going to need array formulas.